British science fiction writer Arthur C. Clarke once said, "There are two possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying." Across all moments on every planet, in every galaxy in the universe, which civilizations have arisen? Gazing into the night sky, witnessing what we see, we ask ourselves questions that remain unanswered. Are we alone, really? Is Earth the sole abode in the story of life? The answers lie hidden somewhere in the vast expanse of space and time. For the first time, the truth is within our reach. This quest will reveal who we are and who we can become. To seek life beyond the universe, we must first look inward, for what we see around us is a marvelously complex phenomenon. So what does life need to form? All living creatures are created by chemistry, and we are giant bags of chemicals. So what are the ideal conditions? Firstly, you need energy, like sunlight and geothermal heat, but not too much, just the right amount and distance. Moreover, you need a diversity of chemical elements, heavy elements like oxygen, carbon, sulfur, and you need liquid, like water. Why such exquisite diversity? In gases, atoms move so fast they can't collide. In solids, atoms stick together but can't move. But in liquids, they can move, collide, and form molecular bonds. Water is excellent for promoting evolutionary processes. Molecules can dissolve in water and form more complex molecular chains. So where can we find these golden conditions? Planets are amazing, and you might not guess that our Earth was nearly perfect. 4 billion years ago, Earth was just the right distance from its star, the Sun, to have a vast ocean. And deep beneath those oceans, in cracks on Earth's crust, marvelous chemical reactions began to occur. The formula remains a mystery, but the ingredients are straightforward. It includes energy, organic matter, molecules, and water. Somewhere in the depths of the oceans on those early Earth days, basic chemistry became biology, or perhaps even more than that, born in underwater volcanic vents, in conditions we once thought biologically impossible. The more we learn about life, the more we see it thrive in harsh places. In the endless expanse of the universe, how many places could life exist? From the astonishing moons of planets beyond the solar system to the stars waiting to be discovered, there are countless opportunities for life outside of Earth. The question, are we alone in this universe, remains unanswered. Saturn, with its diverse terrain and unique climate conditions, has always been a promising target in the search for life outside of Earth. Although its surface is rocky and arid, there are impressive indications of the possibility of life beneath the surface. With the discovery of subterranean oceans beneath the icy crust of many moons, such as Enceladus and Titan, Saturn appears to provide favorable conditions for life. These oceans provide an environment capable of containing water and the necessary chemical resources for life. Let's delve into the mysteries of Saturn, and let's find out if this could be a new destination for life or not. Do you know what Saturn is like? Saturn is the sixth planet in the solar system. Saturn is a gas giant planet, with an average radius 9 times that of Earth. While the planet's mass is 95 times that of Earth, its volume is over 763 times larger, with an average density only 1/8 of Earth's. Thanks to significant advancements in space exploration, humans have successfully conducted research on Saturn for decades. Overall, we have gained valuable knowledge about Saturn, primarily regarding its geography, surface geology, and atmosphere. The internal structure of Saturn likely consists of a core of iron, nickel, and rock, silicate and oxide compounds, surrounded by a thick layer of metallic hydrogen, an intermediate layer between liquid hydrogen and liquid helium, and an uppermost atmosphere. The planet's pale yellowish color is due to the presence of ammonia crystals in the upper atmospheric layer. Electric currents within the metallic hydrogen layer account for Saturn having a planetary magnetic field weaker than Earth's and equal to 1/12 the intensity of Mercury's magnetic field. The uppermost atmospheric layer of the planet appears homogeneous and seemingly tranquil compared to the turbulent atmosphere of Mercury, although it also experiences powerful storms. Wind speeds on Saturn can reach up to 1/800 km/h, faster than on Mercury but not as fast as those on Neptune. Saturn has a ring system consisting of 9 continuous main rings and 3 discontinuous arcs, primarily composed of ice particles with small amounts of dust and rock. Saturn has 82 known natural satellites, with 53 named. This count excludes hundreds of inner moonlets within the ring system. Titan is Saturn's largest moon and the second largest moon in the solar system, larger than both Mercury and the Moon, and the only natural satellite in the solar system with a dense atmosphere. Enceladus, one of Saturn's famous icy moons, has long been the focus of solar system scientists' attention. Recently, a new study has unveiled mysterious discoveries about the unique tiger stripes on Enceladus's surface. From images captured by NASA's Cassini spacecraft in 2005, we first witnessed parallel fractures at the moon's south pole. Known as tiger stripes, these fractures have opened up a unique area for research into extraterrestrial life. But what makes these tiger stripes so special? The latest research has found that they are closely related to the icy plumes ejected from Enceladus's ice crust. These findings not only open up a new avenue for understanding this moon, but also raise doubts about the potential for life on Enceladus. The mysterious ocean beneath Enceladus's surface has always been a topic of controversy and curiosity. From the ice volcanoes in the Tiger Stripe regions, scientists believe there is a system of enigmatic fractures beneath the ocean floor, which we still do not fully understand. The latest discoveries from the cosmic San Andreas Fault have opened up a new aspect in understanding Enceladus's tiger stripes. Frictional mechanics are known to be the primary cause driving motion along the contacts within the tiger stripes, creating a periodic cycle of sliding and locking. Is Enceladus conducive to life? This question has been raised and still lacks a definitive answer, but scientists believe that with its buried global ocean, Enceladus could be a top target in the search for life elsewhere in the solar system. Could this be the dawn of life? Somewhere out there may exist a planet with life nearly as old as the universe itself. With a start 10 billion years ago, the universe could be teeming with far more advanced life than ours. Yet, after decades of searching, there's still no sign of intelligent extraterrestrial life confirmed. So, where are they? Primitive life may be common, but advanced and intelligent life is exceedingly rare, while the universe is vast for a meeting. Or perhaps we are the first, the opening chapter in a long history of life. This means the universe is still young, and hardly any planets have been born. From this perspective, we are the beginning, a prelude in a symphony called life. After about 100 trillion years, when the last star dies, what could come after us? Perhaps any life will have to contend with the relentless solar fires constantly threatening their existence. Many planets among them will be gravitationally locked, one side perpetually scorched by the sun, while the other forever frozen in darkness. But Earth has taught us life has an astonishing adaptability. Furthermore, after billions of years of evolution, in what form could life exist? Someday and somehow, the story of life will end. If we are the first chapters of the story, we will have the opportunity to carry the torch of life far into the future. And if biology cannot extend into the future, then right now, we are living in the grace of the universe. In the future, the universe will likely be completely different. The expansion of space-time will render distant stars invisible, and the night sky will darken. Then life will wonder, how did life unfold in the early days of the universe? We are fortunate to know the answer. At this moment, with what we can access, do you believe that the seeds of life are stored in some cosmic museum? Who knows, when we reach this place, all the mysteries of the past centuries will be decoded. Don't forget to subscribe to the channel for notifications. And for now, goodbye and see you again.